everybody, this is part 1 of Module 1 for Math 026 for Hartford Community College, and we are looking at radicals and radical operations in Module 1. We're going to start off with identifying radicals and identifying roots of radicals. First thing we're going to talk about really is what a radical looks like, and you are probably familiar with something. A radical can look like this. This is called the radical symbol. So I call it a check mark with a tail. The number under the radical symbol is called the radicand. So we can make this, I'll put that there. All right, and then the number outside the radical. And in here they have, if you can kind of see a little n there, this is called your index. Now, the one that I drew, you're probably used to seeing this, and we read it as the square root of 25. And if you'll notice, there's no number right here. If there's no number right there, it is always known that that is a 2 there. If the index is a 2, or you're looking at the square root, we don't have to put the 2 in there. You can if you want. So I could write it without the index, or if I wanted to, I could put the 2 there, but it's, again, not necessary. Doing something you don't have to do. Now, any other index other than 2, you do need to include. So if I were to look at like the cubed root of 8, and that 8 or that cube is a little big, let's make it a little smaller. There we go. So the cubed root of 8, if I were to look at that, I need the 3 up there to know it's the cubed root. We could also do, something like the 4th root of a number, so the 4th root of 16, or the 5th root. N can be any value. And really what a radical means, when we're trying to find the root, the square root, the cubed root, what we're doing is we are trying to figure out, like the cubed root of 8. I want to know what number can I multiply together 3 times that will give me 8. And that would be the cubed root of 8. And I know that if I do 2 times 2 times 2, it gives me 8. So 2 to the 3rd power is equal to 8, or the cubed root of 8 is equal to 2. Because we're just looking for what is the root of that problem. What can I multiply together the number of times equal to the index to get the number, the radicand on the inside. All right, we're going to start and look at square roots and identifying square roots. A number is a square root if it is a real number and the radicand underneath the radical needs to be greater than or equal to 0. So what they're saying is when you're finding the square root of a number, that number under the radical can never equal a negative number. So I cannot have something like -5 and find the real number square root. If we had something like this, our answer would be not a real number. And we will talk about these later on in the course, but for now, if you have a negative under a square root, your answer is a non-real number answer. So we would say it is not real. So what they would like us to do is they want us to evaluate without a calculator if possible and state non-real if it's not real. So the first one, they are looking for the square root of 81. So can you think about what number can you multiply together twice to give you 81? And hopefully in your head right now you're saying, oh, I know that could be 9. So the square root of 81 would be 9. Now, you can also have a negative square root for an answer. So 9 times 9 gives me 81, or we could also say -9. Now, typically they're only looking for that real, the positive answer, but sometimes they want the negative too. So sometimes they may ask you for both roots. Sometimes if they just ask you for one, they're looking for the positive. But the reason I can have a negative answer is because if I do -9 and I square it, it would be -9 times -9, and we know that 2 negatives make a positive when multiplied together. For now, we're just going to focus on those real positive solutions, but again, it could be positive or negative. Here for B, we are looking at the square root of 49 over 64. So here, we can take the square root of this fraction because both numbers are perfect squares. So I'm going to get whole numbers for answers. I know that the square root of 49 is 7 and the square root of 64 is 8. So my answer would be 7/8. Now for C, you're probably looking at this and you're like, oh, that's a decimal. That looks a little scary. But if we focus on the back half of this decimal right here, we have 16. And I know that the square root of 16 is 4. But I need 16 10,000ths. So the square root here is going to equal 400. You may be like, how did you know it's only 1 0 and not 4 zeros or 2 zeros or 3 zeros in front of that 4? Well, I know because when I multiply, if I were to do 4 times 4, I get 16. But if I do 400 times 400, remember when you multiply decimals, you would count the number of digits after each decimal point. So I have 1, 2, 3, 4, and then that means I'm going to move that decimal point over 4 places. And because I'm doing that, I'm going to add those 2 zeros in there. So again, if you have to, just double check your work by multiplying it out. Now for D, the square root of 169 is equal to 13, or negative 13. Now for E, they want us to find the negative square root, the square root of negative 169. Now, because our negative is under that radical and it's an even numbered index, it's a square root, we are going to say our answer is not a real number. And it will be, we will deal with imaginary numbers later or complex numbers, and then we'll find a way to deal with those. Now for S, the problem is a little bit different because they are saying, kind of think of it like you have parentheses here. So I'm going to write it a little bit bigger. All right, so we want the square root of 169, and then they want us to take the opposite of it. So the square root of 169 we know is 13, but then when we take the opposite of it, our answer here would be negative 13. All right, so next we are taking the square roots of variables, or we have some problems where there's variables in there. Now, if we want to find the square root of x to the 10th power, basically what we are figuring out here is how many groups of 2x's are underneath that radical. So I'm going to show you the long way to do it and then the short way to do it. So really, if I write this out, we know x to the 10th power is the same as x times x times x times x. There's 5. All right, so this x to the 10th is the same as x times 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 x. And what I want to do is, how many groups of 2, how many square roots can I pull out, or radicals? So I have one group here, one group here, one group here, one group here, and one group here. So that gives me 5 groups of 2 if I count them. So the square root of x to the 10th is equal to x to the 5th power. Another way to look at that is if we were to do this, and remember our radical, if we don't see an index, the index is 2. But really what you do with variables is you take the index, whatever it is, divide it into your power for your, or your exponent for your power. I know that 2 goes into 10 5 times and it goes in evenly, so I'm going to get x to the 5th power. We'll see sometimes later on when we're simplifying radicals where it doesn't go in evenly, and I'll show you what to do there. So our answer here is x to the 5th power. For h, we have the square root of 121, a to the 14th. First, we're going to look at the square root of 121. The square root of 121 is 11. And then if I divide 2 into 14. 2 goes into 14 7 times, so my answer would be 11 a to the 7th power. And then for I, when we look at that, the square root of 400 is 20. And then if I divide 2 into 2, it goes 1 time. So my answer will be 20R because I can make one group of 2 R's there. All right, so that is it for finding the square roots. Next up, we're going to look at cubed roots. All right, so now we're looking at cubed roots. And a cubed root, we talked about it briefly in the beginning of this video. A cubed root is going to have an index of 3. So the cubed root of A here is going to be a real number for all radicands of A. So the nice thing about a cubed root, or an odd index, which is something we haven't really talked about, but like an index that's odd, like 3, 5, 7. When you find the cubed root of a number, your A, your radicand, can be any type of number. It can be positive or negative. Because if I'm going to find, and we talked about the cubed root of 8 earlier, if I'm going to find the cubed root of negative 8 though, my answer is going to be not positive 2, but negative 2 here. And that is because if I take negative 2 and I cube it, I would do negative 2 times negative 2 times negative 2. We know that 2 negatives make a positive, but then I have to multiply times that third negative, which is going to give me that negative 8. So the radicand for a cubed root or any odd index can be a negative or a positive number. And then if it's a negative number, your answer will be negative. If it's a positive number, your answer will be positive. All right, so here we are going to find the cubed root of some values, and they want you to do it without a calculator. Now, the first one we're going to look at is the cubed root of 125. And this is where, if you're not sure, sometimes it's helpful, especially in the beginning when you're getting used to these, make a little list off to the side. So like I would do, I'm going to make a list. I know that 2 to the third power is 8 because we just talked about it. 3 to the third power would be 3 times 3 times 3. And that is going to give me 27. 4 to the third power is 64. 5 to the third power, I happen to know, is 125. And you could keep going, make the list a little bit longer. 6 to the third power is going to be 216. And again, it's good to have this list down the side. And once you get used to it, you don't really need the list anymore because you'll know, get to know them by heart. 7 to the third power is 343. All right, so if I go down here and I look, we want the cubed root of 125. So we know on our list, we found that. So that is going to equal 5. The cubed root of negative 343. Well, I know that the cubed root of 343 is 7. So negative 343 would be negative 7. For C, it's a fraction, but they're both perfect cubes, so I can take the cubed root of each. The cubed root of 27 is 3, and the cubed root of 64 is 4, so my answer would be 3/4. Now, we didn't go this far, but the opposite of the cubed root of negative 1,000, the 10, we should go a little bit further. 10 to the third power is going to be equal to 1,000. So I know the cubed root of negative 1,000 is going to be negative 10. But then they want the opposite of that because we have that negative on the outside, so we have to deal with that. So those two negatives there is going to make that answer a positive 10. For E, with the cubed root of 8a to the 9th. So again, focus on the number first. We know the cubed root of 8 is 2. Now, we do the same thing here. We divide our index into our exponent for our power with the variable. And 3 goes into 9 3 times. So my answer is going to be 2a to the third. And again, notice I'm writing all these answers without the radical because once you take the root, the cubed root or the square root or the nth root, you remove that radical. The third root of 512 is, I believe, and we didn't put it on here, but I'm going to make a little spot. So 8 to the third power is equal to 512. So that means that my answer is going to be 8. And then 3 goes into 33 11 times, so x to the 11th power. So far we've talked about square roots and cubed roots, which are probably the most common roots that you'll deal with, but not all indexes are 2s or 3s. So we do refer to others as the nth root, and there are properties of radicands if the index is even or odd, and we talked a little bit about this. If your index is even, then you can only have a positive real number underneath that radical. So again, we talked about the square roots. We couldn't have a negative. It's the same thing if your index is like a 4, a 6, an 8. If your index is odd, you can have any real number. So you can have a positive or a negative real number under that radical. To evaluate the nth root, we again just have to figure out what number raised to that power would give us the radicand. Now, I do know that these are very small on the bottom. I'm not sure why they showed up so small, but I apologize. So let's take a look here. We're going to do fourth roots now. So we're going to do for A, it's the fourth root of 81. So I have to figure out here, what number can I multiply together 4 times to give me 81? And again, this is something you may not know off the top of your head, so I make a little list, like 2 to the 4th power, I know is 16. 3 to the 4th power, I know is 81. 4 to the 4th power is 256. And you can keep going, 5 to the 5th power, 6 to the 5th power, maybe do, and again, having this list to look at in the beginning will help you, and later on you won't need it because you'll be familiar with them and you'll remember them, or you'll be able to like test it out really quickly to see if it's right. So the fourth root of 81, we just figured out, is 3. Now, the fourth root of negative 81, because my index is even here, and I have a 4 there, and we're looking at this, we're doing the fourth root of negative 81. Because I have an even index here, I cannot have a negative under my radical, so my answer would be non-real. And then for C, we are looking for the opposite of the fourth root of 81, and we know the fourth root of 81 is 3, but then when we find the opposite of that, it's going to be negative 3. Right, and here we are dealing with the fifth root of 32 and just different forms of it. So again, start off with that list. I happen to know that 2 to the 5th power is equal to 32, so we don't have to go any further. And really, by the time you get to the 5th root, like your numbers get pretty big quickly, so typically it's going to be, you're going to deal with like the 2s, the 3s, or the 4s for your root. So the first one for D, they want the 5th root of 32, so that answer is going to be 2. Now for E, they want the 5th root of negative 32. And again, because it's an odd index, you can have that negative under there. My answer would just be negative 2. And then F, the last one, is the opposite of the 5th root of 32. And again, the 5th root of 32 is equal to 2, but then they want the opposite of that, so my final answer would be negative 2. So the last few slides that we've looked at, or the beginning slides we've looked at, all of our radicals have been perfect, either perfect squares, perfect cubes, or perfect roots, meaning that their answer is a whole number. But not every root or radical will be have a perfect whole number answer. And when you find the square root of a number that is not a perfect square, so your answer is not a whole number, your answer will be an irrational number, which means that it will go on forever and ever, never repeat in a pattern. So it'll have a decimal that will go on and on and on, and it won't repeat in a pattern. So then we can either leave it in radical form if they want an exact answer, or at times they will ask you to approximate it. Now, you can kind of approximate it in your head knowing your perfect squares, or what we're going to do is we're going to use our calculator to help us approximate square roots or cubed roots or fourth roots. And I will talk a little bit about how to do that on here, but I will also add in on Blackboard a video on just how to find like the cubed root or the fourth or the fifth root on a graphing calculator, so you guys know what to do there. All right, so the first one we're going to do is we are going to find the square root of 107. Now it says to approximate first by hand, then using a calculator. Well, here, the square root of 107, I know that my answer is going to be between 10 and 11. It's going to be 10 point something. Now you may ask, how do I know that? Because I know that 10 squared is 100, and 11 squared is 121. 107 is between those two numbers, so that means my answer is going to be between those two numbers. So then I'm going to do the square root of 107 on my calculator, and again I'll post a video later to kind of walk you through how to enter it in if you're not sure. And when I get it, we're going to round it to 3, let's do 2 decimal places. So I get an answer of 10.34408043. And again, it goes on forever, so the calculator can only give me so many numbers after the decimal point. But my answer here, if I round to 2 decimal places, to the hundredths, there's my 4. If I look to the number next door, it's a 4 as well. So I would leave it alone. So my answer is going to be 10 and 34 hundredths. Now, the cubed root of 176. If we recall our cubed roots from before, the cubed root, or not the cubed root, but 3 to the third power was 27. Okay, and then we knew that 4 to the third power is 64. 5 to the third power is 125. And 6 to the third power was our 216. So if we're looking at this list, the cubed root of 176, it's going to be between which of these whole numbers? Hopefully you can see right here, it goes right here, would be between here. So my answer is going to be between 5 and 6. And it's going to be 5 point something. So I'm going to do the cubed root of, on my calculator, 176. And when I do that, I get a nice long decimal of 5.604078661. But again, if we round to the hundredths, that's a 0, and we look to the number next door, it's a 4. So my answer is 5.60, or just 5.6, because it's a 0, we can drop it off. All right, and our last one, we want the square root of 2/17. Well, 2/17 is a fraction. Fractions is a proper fraction. It's less than 1, but greater than 0. So our answer here is going to be between 0 and 1, because, again, a fraction is less than a whole number 1, if it's a proper fraction, and this is. Now, to enter it into our calculator, I'll put my square root symbol, and I will put 2 parentheses around my fraction, 2 divided by 17. And when I do that, I end up with 0.3429971,703. And I'm going to round to the nearest hundredth. So if I look to the number next door, it's a 2. So we'll round it, keep it the same. So 34 hundredths would be my answer. And that is it for the first part of Module 1. Take a minute to review your notes and then go back to our Blackboard page and tune in to Part 2.